Oh no, it's crazy how many people are just like going outside just to play this. Like, all these people are usually playing games outside for the first time in years.
Okay, I'll go ahead and do number 11 and number 6. Those had the lowest success. So let's do those two. So drawing a good picture is always key. If the functions are basic, you should be able to do that without a calculator. Y equals 1 over x to the 4th is going to be something like, it's like 1 over x. And then y equals 0 is going to be x-axis, x equals 3, and x equals 5. And then they want that about negative y equals negative 1. Okay, so we imagine that thing rotating about y equals negative 1, and we get at one, when it's 180 degrees around in rotation, it's going to look something like that. Over here, though. Okay, something like that. And then, so our typical, are we going to have pancakes or washers? Washers, because there's going to be a hole, right? If we're rotating about y equals negative 1, there's going to be a hole in the middle. And are we gonna? Is it going to be dx or dy? Vertical strips or horizontal strips? Vertical strips. So here's a typical strip. And we think about rotating that typical strip about y equals negative 1. And at 180 degrees, we're there. So that whole thing is that's our washer. That's the best washer I've drawn all day. Okay, so that's going to be the washer, and so so what we're going to have like an inner radius and an outer radius, right? So from here, from the center of rotation to there is the radius, what we said, of the hole, RH, or R inner. You could say R inner, or the radius of the hole. And then this to there is going to be our radius of the whole pancake, or the outer radius. Like yesterday I used H and P. So the outer radius of P is going to be from negative 1 up to the edge of the radius. And then the whole radius is from there to there. And so we know that the volume of the washer is volume of a pancake minus volume of the hole. So the volume of the pancake is a pi rp squared h. Let's do it up here. Pi rp squared h minus pi r h squared h. Volume of the whole thing minus the volume of the hole. And then, what is that? So we just got to now write h is, of course, our delta x. So we've got to just get these two radii. So what is the radius of the hole? It's the distance from the center of rotation at negative 1 to there. It's always 1, right? If you want to think of it as a change of y, it would be y, y upper minus y lower. That'd be 0 minus negative 1. Well, but it's simply just 1. Radius is just 1. Okay, so that r h is just 1. What is r sub p? So that's what we're doing here. R sub p is a change in y. It's going to be, so what is this? This is y equals 1 over x to the 4th. So it's going to be y2 minus, what is y1 is just y equals -1, so minus -1. Or you can see it's going to be y2 plus 1. Right? It's going to be 1 greater than whatever that y coordinate is. Will that be that whole outer radius? And then y2 is simply 1 over x to the 4th. So that's going to be squared times delta x minus pi. The radius of the whole is 1, right? And so then this y2 is our 1 over x to the 4th. That's the volume of the washer, so that's our setup work. Total volume then equals integral from, so what? X goes from what to what? Too easy, right? 3 to 5. Starts at 3, ends at 5 of these volumes. So I'll factor out pi. 1 over x to the 4th plus 1, quantity squared, minus 1 squared dx. Questions on this one? So then you be careful on your math, right? You're going to multiply out. Actually, the 1's will go away. So you just actually have 2 terms in that integral. 1 over x to the 8th and what? 2 over x to the 4th times pi from 3 to 5. And just be careful on your doing your antiderivative right. Questions on this one? Okay, and the other one is number, can I erase? Are we good? Number 6. Y equals x to the 2/3. I think that opens downward, or is concave down, like that. X equals 1 is like this. And y equals 0 is the x-axis. So here's our region. That's 1. And we're going to rotate that about the y-axis. At 180 degrees, that's what we'll have. Will this be pancakes or washers? Washers. Will it be dx or dy? Washers will be horizontal. So here's our typical washer. It's going to look like that. And again, so we need outer radius and inner radius. Outer radius equals what? So think about all the typical washers. The radius is from our axis of rotation out to the outer edge of the washer. 1 for all of them, right? It's the same for all of them. Inner radius, radius of the hole, equals. Okay, so is it an x-coordinate, y-coordinate, change in x, or change in y? X-coordinate, y-coordinate, change in x, or change in y? I've heard change in y, y, and change an x. None of which are correct. What is that? The distance from there to there is what? That's the x-coordinate. You could think of it as a change in x, that's fine, but that's not the simplest way to think of it. It's just the x-coordinate. Do you see that? That's just the x-coordinate. Distance from the y-axis to your point on your curve is the x-coordinate of that point right there. So our h is just x. Just x-coordinate. Does it make sense? You have to. So in these problems, these regions and these volumes get complicated. You still have to identify x and y coordinates of points. X coordinate is distance from the y-axis. Y coordinate, distance from the x-axis. So that radius is just x. That radius is just x. Okay, so then the volume of our washer is pi times outer radius, 1 squared h delta y, minus pi times inner radius, x, delta y. But we want to write that's x.
Why is not x to the 2/3?
Because it's the x-coordinate. The distance from here to here is the x-coordinate. X to the 2/3 is the y-coordinate. X to the 2/3 equals y, you see? So we need x now, we need it in terms of y. What is that? X to the 3/2, y to the 3/2?
Yeah.
So x is y to the 3/2, and then we're going to square that as the radius, okay? So total volume is integral from what to what? And is it 0 to this one? We're stacking up the washers this way, so we need the y coordinate here, which also is 1. So when we do 0 to 1, make sure you know that that's this one up here. 0 to 1, pi minus, this is basically y cubed. Any questions? Are we good on washers and pancakes? Okay, let's look at the same problem again and say what would happen if we took a vertical strip and used dx. What would happen? So let's see. The exact same problem. Going to rotate about y-axis, and this is y equals x to the 2/3. This is 1. Okay, so what if we instead took a typical strip this way?
That would be like adding many hollow cylinders, right?
She said it would be like adding together a bunch of hollow cylinders. So what do? We think of the volume we get by rotating the whole surface. Something like that, right? And then to figure out how we're going to calculate that volume, we start with a typical strip, and we do the same thing with a typical strip that we do with the whole region, right? We rotate it about the y-axis. So we're going to take that thing, and we're going to rotate that around the y-axis. And at 180 degrees, it's going to look like this. So what will you get when you rotate a typical strip like that around the y-axis, a vertical strip? She's proposed a hollow cylinder, a thin hollow cylinder. Adrian likes it. Joseph likes it. Hunter likes it. Yeah, that's what you get. You get what we call a cylindrical shell. Okay, another way to think of it is like a sleeve, right? It's like a sleeve. It's still number 6, yeah. So these are all going to be containing each other. Like there's going to be the first one is going to be this really short one down here at the origin, and they're going to get taller and taller, and each one is going to enclose the one before it, right? Each one's going to wrap around the one that we just did. Until the very last one is the tallest and the widest, right? The tallest and the widest one will be out here at x equals 1, and it'll wrap all the way around all the rest of the shells. So they're all enclosed in each other. See that? Okay. So then so we know we're going to get the total volume by adding up the volume of the individual shell, so we need the volume of a shell. So what is the volume of one of these things? Mm-hmm. So what we want to do is we want to take, to see this, it's the best pair of scissors I've drawn all day. We're going to take our scissors and we're going to cut right there. Okay, so we're gonna cut this thing, and then we're going to unfurl it and lay it flat on the screen. And what shape will we get? Rectangular solid, right? And so the volume of the solid is just going to be this shell is just really a rectangular solid wrapped up in a circle, right? So length times width times height. So we can call this the length, and we can call this the width, and this the height. So we just need those three dimensions of that thing, and we'll have the volume of our solid, because we're just multiplying them together, just like you get the solid of a box. Okay, so let's start with the width. So the width is that small, very thin dimension. What is the width? Going back to our shell, the way we drew it in the original solid, what is that width? So the width, wouldn't it be this dimension right here? And what is that? Change in x, right? Change in x. Okay, what about the height? Okay, let's see if we got it here. What is that height? X coordinate, y coordinate, change in x or change in y? I heard change in y and I heard a y coordinate. It's the y coordinate, right? It's the distance from the x-axis. That distance is just the y coordinate of this point. You got this point right here? Its y coordinate is its distance up from the x-axis. Do you see it? It is also a change in y. That's perfectly legitimate. But an easier, more simple version of this particular change in y is simply y. It's simply y. That's the height. Lastly, what's the length of this? So the length of this rectangular solid is what of this shell? Circumference of the shell, right? Circumference. Circumference is 2 pi r. Circumference is 2 pi r. So we need the radius of our shell, right? To get that length, it's going to be 2 pi times the radius. So what is the radius of the shell from here to here? X coordinate, y coordinate, change in x, change in y. X coordinate. Radius of the shells are x coordinate. So it's going to be 2 pi x, because x is the radius of the shell. So we're doing it in terms of our delta x tells us we got to get everything in terms of x. So this 2 pi x is fine. We're just going to leave it as it is, right? 2 pi x times what is y? Y is our x to the 2/3. dx. dx. No, that's this right here. We got to get y. We got everything in terms of x. So what is y? Y is x to the 2/3. Do you see it? Okay. So then we're going to add these up from total volume is going to be integral from. So our first shell is at what? X equals 0. Is this like almost 0 height shell with almost 0 radius, right? It's like this point. And then each shell gets taller with a greater radius. So the first shell is that like that point shell right there at the origin. That's going to be at x equals 0. And the last shell is the tallest and widest shell. X equals 1. 2 pi r times height times thickness of the shell. Questions on this first example of shells? This is obviously new stuff today. Yeah.
Yeah. What is necessarily the advantage of doing it like this method as opposed to integrating with respect to y?
So sometimes, so there's no really set situations. All situations are different. But sometimes, this is an easier integral in this case because the washers one ends up with 2 terms. So this is an easier one to calculate. Sometimes the antiderivative is much easier one way than another, and you'll see that in the web work. There'll be a problem where if you did it the other way, you get an antiderivative that we don't have the technique to do. But if you do it using shells, it's a pretty straightforward antiderivative. Makes sense? So that happens. So sometimes you get a more complicated expression one way versus the other. Sometimes you get a undoable antiderivative one way instead of the other. So let's just show that these totally different methods give us the same value because it's the same volume. So hopefully, did someone write down the answer to when I did this before? Using washers, do you remember what it was? 0 to 1 pi times. Is it?
It's going to be 0.75, 3/4 y.
Is it 1 squared minus
Y to the 3rd.
y cubed
Yeah.
dy? Was that the whole thing? Okay, so that's what we got using the washers, right? Is that what we got using washers? All right, and then using this method, 0 to 1, 2 pi x times x to the 2/3. Look at that. Okay, so same volume, two different ways to do it. Both give the exact same answer since we set it up correctly. Questions? So, oh yeah, we're gonna do shells most of the day today.
So this is like the easy example.
Yes, exactly. But now that you've done, but even the hard ones of these, it won't seem as hard because of all the stuff you've done with washers. The only difference is now you get this different shape, and you use you get the 2 pi r height times thickness using a different formula, but everything else is the same. You're still, the hard part to this is still figuring out these distances, these radiuses, and these heights in terms of your coordinates and your functions. That's the hardest part. So you've had a lot of practice with that. With the washers, you should be better at this. Okay, other questions on this first example? Okay, so let's do another one. Can I erase? Okay, so remember we had this one yesterday. We had this region yesterday. Where was x equals y squared? Remember x equals y squared. Is this x equals y squared?
In the other part.
This is y equals the square root of x. Are they the same?
They're tilted. This is tilted. You're moved at 90 degrees clockwise. And you're missing the other half would be
Just missing it.
y equals.
Okay, so this, what I drew is y equals square root of x. I did not draw x equals y squared. X equals y squared also has this. This is x equals y squared. Make sure because if you solve x equals y squared for y and you get square root of x and you forget the plus or minus and you put this in your graphing calculator, you're only going to get the top half. And that's not x equals y squared. That's just the top half of x equals y squared. Okay? So if your region involves also the bottom half, you won't get it right. So make sure that you're comfortable with these, that you draw the whole curve, and if it's part of it. Now in this particular case, you don't use the bottom, but I just want to point that out. So in this one, then we had x plus y equals 6, and it said the x-axis and then the first quadrant. So we end up only using the top half, but that's for this problem. Okay. Make sure you know what x equals y squared is, or something similar to that. So now we're going to rotate about y equals -2, and let's talk about doing it. Try it again. Come on, here we go. Here. Okay, so let's talk about first if we use delta x or vertical strips. What would the approach to this problem be if we were using vertical strips? Okay, he's proposing washers, is that right?
Yes.
Right. It'll be washers. And then when we do this problem, what will happen? Does anyone see? When we use washers? Typical strip? Is this a typical strip?
It's only one.
We'll have to have two integrals.
Right. This is a typical strip kind of for the first half of that region. When you get to that intersection point, that peak, and you keep going, now then it's going to change. The outer radius is going to change, right? So if you use washers and do change in x with respect to x, it's going to have to be the sum of two integrals. See that? You have to sum up two integrals. The outer radius for the blue is based on the curve. The outer radius for the red is based on the line. So you have to have two integrals. So washers would be requires two integrals summed up. Okay, so now what about dy? What will happen when we if we do horizontal strips? Tell me about that.
Well, the radius is different from one side to another.
I'm talking about what approach will that, how will we do this problem if we do horizontal strips? What will we get?
Would the integral require both equations then? Because
I'm asking about the approach. The approach.
Oh, okay.
Shells, right? It's going to be shells. And then will we need more than one integral, or can we do it with one integral?
You can do it with.
So the first shell would be this inner shell. It'd be the tallest one. It'd be the most inside shell. You see that? And then as the radius gets bigger, the heights of the shells get smaller, all the way till this shell with the greatest radius and like zero height. Does this typical shell cover the whole solid? Does the typical shell then, do we only need one typical shell to get the whole solid?
yes.
Do you see that? Because the bottom edge, the bottom of the height will always be this curve, and the top of the shell will always be this line for all the shells. So in this case, shells dy needs only one integral. Okay, so you guys are going to do it. So find the volume of that solid if you use shells or dy.
Yes, exactly. So we know for sure that the whole is two, but we just need a y coordinate.
No, but this is what I've got the radius.
What?
I think I went with the table on.
No, it's just y equals two.
Just because.
Yeah. I went with the table. Yeah, table 58. I think you could solve it though in the long way around.
Or 2 plus 1.
No, that would be really difficult. You would have to go with doing the product or it'd be nasty, but it'd be a two-stepper.
That's the one.
Yeah.
And then if you cut the cylinder,
Like really ugly word.
Delta x or delta y, Adrian?
you have the cylinder.
So this is length,
And then this
which would be like vertically, like if I cut this and unfurled it, that would be this, the whole distance this way, times the height is this one.
So how do we the height? I guess that's what I'm confused about.
Well, it's right there.
So
It's this.
Exactly. You over
What's the height?
Which
The height of the shell is defined by your functions. How tall the shell is. It's going to start here and end here.
This is your height. 6 y
was two.
So, is it an x coordinate, a y coordinate, a change in x, or a change in y? So now you just look at this distance on this and you do just the same thing you did with the pancakes and washers. Is it an x coordinate, a y coordinate, a change in x, or a change in y? That height. Change in x. How do we change it? Do we change in x?
So it's supposed to be one that
The x value is correct. The x value you get from this one minus the x value you get from this
something
one.
that wasn't bounded by the minus. I guess you could still have your radius just already with the max.
Good. Got it.
Now, like, y cubed minus y squared.
Is the y coordinate of this 2 right here?
Yeah, it's 2 and negative 3. So that's what
2 and negative 3?
No, because y doesn't line on it.
It's 4. Negative 3 is the 0 to negative square root of x.
Yeah, down here. This doesn't play into this problem, right? 'Cause we're only
so
using
we're
the.
just taking 2.
We would just need the y coordinate at that point, right there. Okay. Other questions? Adrian, are you?
Yeah.
Did that help?
Yeah.
Okay. You good?
Well, you need to. You need to get it. So if this is your cylinder with this radius, what is your height?
Let's do.
Because it's
Your
always
height is
Like, to
gonna
be honest, it
be
would
from here
take
to
you less
here
time
to here.
to do it.
Y squared.
As two separation. If I had just
There.
kept it, yeah, if I had just kept it x, yeah, I could have done that.
So go back to the original question. X coordinate, a y coordinate, a change in x, or a change in y.
This is going from 2 to this side.
Why
to
6
negative
minus y?
right?
Okay, but you don't need further. It's not further x because you're going to do double y.
Because it's going, it's swinging from 2, right? And then
6
down
minus
down
y.
to that apex of the
Right.
Minus y squared.
The radius. That's this. That's the
And then the width?
Yeah. Get my head right and then just go to 11. Might make a pot of coffee.
Here.
Rise up to 9.
Not sure what you got over here. Minus sign.
Well, I was originally squaring, but then I realized that was wrong, so that was the byproduct.
Here.
3-day weekend
It's
is
just
enough.
they length times width times height. Length times height.
We just need the value
So it's just
for
like a pi r times h times delta. So I'm just gonna figure what r is and what h is.
Oh, so sucky.
So,
It looks like you're kind of on the right track with h, but it's way, you got all these extra zeros and minuses.
right, it was just mine.
It's gonna be a change in x, right? H is that h is the height of our shell. It's all change in x.
We had it's a place run by students and the school it's open until 2. So like I feel so bad for the people who was there like Saturday night or morning.
because we just if we just
Right,
need
how
the
the change in
radius.
y is the higher y minus.
And in order to get the radius, we need to only take into account this one
Chicken bacon ranch.
So, you know when we were doing
It's
the
good
other
pizza. It's
ones,
good pizza though. That's the issue. Like I don't feel guilty about
we
this at
weren't
all.
taking into account this, we were doing this plus this. And it's the same here, this plus this. But the difference is that
That's the radius of your shell, right? The radius, this is the radius of your shell going in.
So
y.
there's also the height of the
Two
drag
y.
I translated to
Y.
places. And so it was a drag
No,
campus,
because we're just doing
people would
the
go,
radius.
they'd have houses off campus, and that's where the parties would be. And with it, yeah,
And the radius is
more
just
would get
half.
broken up. Next thing you know, like 17 people would just jump and get a pizza. It's like, alright, so
Okay. So we see the picture here that I drew. Here's the shell. The height of that shell is it an x coordinate, a y coordinate, a change in x, or a change in y? It's just x or a change in x? It's a change in x. It's the change in x from this curve to this line. So here's what do. Always ask that question first, and then write down literally that first. And then change it to the other variable if you need to or not. So you told me it's a change in x. So that height is a change in x, x2 minus x1. Now, are we going to need to change this to be in terms of y? Yes, because we're doing delta y. So what is x2 in terms of y? That's the x coordinate of this point in terms of y.
It's minus 1.
So you say 6 minus y? Yeah, 6 minus y. That's our x2, or the x coordinate here. And then x1
Y squared.
minus y squared. So there's your height. 6 minus y quantity minus y squared. That's the height of all the shells. Anybody have a question on that? Okay, the radius of the shells. The radius is from the center of rotation out to the shell itself, right? Out to the boundary of the shell. Okay? Is that x coordinate, y coordinate, change in x, or change in y?
The what?
The radius.
It's in y coordinate.
Well, okay, so we can think of
Plus 2.
+2, right? So if you want, so you can think of it as a change, two ways to think about it. A change in y from there to there, or you can think of it as the y coordinate, simply +2. And that's maybe easier. So let's, are we going to change that y in terms of x? No, because we're doing delta y. So the radius, we just leave it, y + 2. Or y minus -2. If you did change in y, it'd be y minus -2. Same thing, y + 2. Is that a question? Or scratch? Okay, so we're ready to do it now. So total volume is, or the volume of this shell is 2 pi times radius, y + 2, times the height, which is 6 minus y squared, delta y. So we're going to now add up all these sleeves so to figure out which y coordinates, you go back to the original region. Forget about your 180-degree image, right? Forget about that. The strips that you rotate to get all the shells determine what your limits of integration are. So the first strip, so the first strip here is this strip here. That's your most narrow shell, the inner shell. All the way, the last strip is this like point shell with the greatest radius. So that the strips on the original region before you rotate it is what determines your limits of integration. So the first shell is at y equals right there, 0. The last shell, so now here are all the strips that form all the shells. The last one is at, that's the point, is that the point 2, 4? 4, 2. And we want the y coordinate, right? So 0 to 2. 0 to 2, 2 pi, y + 2, 6 minus y squared, dy. Questions? Anybody have a question?
So in the test, Can we leave the answer like this, or
It depends.
we have to do all math?
Read the instructions. Read the instructions. You're responsible. If it asks you to calculate that value by hand, you have to be able to do that. That's like easy. You have to multiply. You're gonna get 6 terms there, and you have to combine like terms. But if it just says set up the integral expression to find the volume, then we'd be done. And that's mostly what I'm interested in when it comes to this. But it could say find the volume. Then you'd have to find the volume. Just read carefully.
So we have questions like this in the text one.
In the what?
In text
Tomorrow?
one.
Yeah, this is all on to tomorrow's exam. Yeah. That's the disadvantage to a summer course. We can't spend the whole day on review. Stuff today is on the test tomorrow. But hopefully there's an advantage. It's fresh in your mind, right? Other questions on this example? Okay, so I'll put you to work on a couple more, and I'm going to go get your graded papers. And then we got one more thing to do after this. Three to work on here. See how much of these you can sketch, the regions, without your calculator. It's good practice. So most of this you should be able to sketch without your calculator. But then if you can't, then use your calculator so we can get to the heart of it, which is setting up the integrals.
Nowhere and destroyed them. And that was like,
Okay, so for the second one, you have to recognize that your radius of that shell is a change in x. So I started by writing that as x2 minus x1. And you have to recognize that your height is also a change in y. So I wrote that as y2 minus y1. So we got, so what is that change in x for the radius? So yeah, this is, so the upper x is just the x coordinate of this curve. And then the lower x is our center of rotation. So it's x minus 1. It's the radius. Okay, the height of the shell is, the y coordinate is the upper y for the y coordinate of the point, minus the lower is 3. So it would be y minus 3. Since it's delta x, everything's good except we got to change that y in terms of x, which is 4x minus x squared minus 3. And then we're going to add all those up from what to what? We're going to add all those up from the first little shell will be here at x equals 1. And the last shell will be for this strip here out here, x equals 3. So you're going to integrate from 1 to 3 of your typical shell volume. Questions on the second one? Okay, how about the first one? So now we're rotating about the y-axis. So what is the radius from there to there? Is it x-coordinate, y-coordinate, change in x, or change in y? From the y-coordinate, or sorry, from the y-axis to our strip is simply x. 2 pi x. What's the height? X coordinate, y coordinate, change in y, or change in x? Just the y coordinate, because it's the height up from the x-axis. So 2 pi x times y delta x. So we got to change the y to x. Y equals e to the minus x. We're going to integrate from, where's the first shell? The first shell is here. 2, right? First shell has its strip at 2. Last shell has its strip at 5. And then, how are we going to do that antiderivative?
Forget what it's called. Yeah, I'm doing the product rule.
Right. This is one of our basic forms, expected forms for undoing the product rule. This one is just going to be multiply everything out, and it's polynomial. It's easy, just tedious, right? Okay, last one. So we should be able to get this region. It looks like this. Rotated about y equals 1. We get this. So shells will be vertical strips or horizontal strips? Horizontal strips will give us shells. If we did vertical strips, we'd get pancakes. That's the worst shell I've drawn all day. Okay, and so what is our radius is from here to here. And our height is from here to here. Everyone see that? So volume of the shell is 2 pi r h delta y. So what is the radius? An x coordinate, y coordinate, change in x or change in y? Radius is from here to here. So an x, a y, a change in x or a change in y? Change of y. Yeah, it's a vertical change, right? The height of the thing. X, y, change in x or change in y? Change in x. Then delta y. So since it's delta y, we're going to change these x's to y. So that y2 minus y1. Upper y minus lower y. What's the upper y value? That's 1. The center of rotation. Minus? No. Cube root of y is equal to x. It's a change in y. Integral is in terms of y, and we want to change in y. So that's just the y coordinate of that thing. 1 minus y. The radius is? Change in x, so it's 1 minus no. Oh, right, because so it's 1 minus x, but we have to change it into y, right? So it's 1 minus x. We got to change that thing in terms of y, which is cube root of y, right? And then these shells will go from 0 to 1. So the first shell is the biggest shell here, and then all the way to 1. Okay, so I'll not do that last thing. We're out of time, we're over time. So there was one more part I was going to do, but we won't do it. It won't be on the exam. So basically what's on the exam is everything from that review sheet that I posted over the weekend, and then areas, washers and pancakes, and shells. That's the exam. I'll post some more some practice. So tonight we'll have a web work on shells. Okay, there'll be web work on shells, and then the 3 web work sets, areas, washers, and shells will be primarily your review for the exam.
So, you do have homework for tomorrow.
You have homework for tomorrow, shells, but it's all great for studying, okay? It's perfect for studying. We'll have the exam. So I think I said we'd start the exam at 11:40. Let's not. Let's start the exam at 11:30 and come. I'll be here at 10:30 to do final review for an hour. And then we'll start the exam at 11:30 tomorrow.